Today we will be looking at November 2017 paper 2. It's a government paper. We have previously looked at paper 1, so now we're going to go through paper 2, and this includes statistics, it includes geometry, surface area and volume, analytical geometry, and trig. Okay, so this is just the instructions and information. Always remember to round off to 2 decimal places. That is a very important point, especially in trig. You also should make sure that your calculator is in the degree mode. Otherwise, majority of your trig answers are going to be incorrect. Okay, let's go down. So question 1, we're looking at stats. So it says the data below shows the number of laptops sold by 15 sales agents during the last financial year. So before we even begin to look at these questions, we need to rearrange our data so that it is in ascending or chronological order. So my first term, which is my 30s, we've got, let's use different colors. So we've got 34, we've got 37. Okay, those are only the 30s. So the first one is 34, then we've got 37. So the next one, we're looking for 40s. We've got 43, 48, 46, another 48, and that's about it. Okay, so the first one is 43. Okay, the first one that we have of the 40s is 43, 46, 48, and another 48. Okay, let's use a different color. Let's go to the 50s. So we've got 52, 58, 54. So go along the same lines. We've got 52, 54. This is a nice easy way of doing it so that you don't end up confusing yourself seeing if you actually got the correct numbers or not. Of 60s, 62, 68. The last couple of ones that we've got, 73 and 78. And then we've got the last two, which is 84 and 90. It's quite a long line. Okay, now let's take a look at, so now we've got all our numbers. Determine the median of the number of laptops sold. So how is median calculated? Median is the middle. Okay, so remembering your terminology, median means the middle. Okay, let's take a look at where the middle is and how many. So it says 15, there's 15 sales. So these are the 15 sales. So we know that for 15 it's an odd number. So we're going to have to find the middle value for that. So half of 15 would be 7.5. So we're looking for the 7.5 term. So 1, 2, 3, 4, 5, 6, 7. This should be it. Let's double check ourselves. 1, 2, 3, 4, 5, 6, 7. So this is 1.1. The median is equal to 54. Okay, let's take a look at the next one. Calculate the range of the data. So what is range? Range is our highest value minus our lowest value, which is why it's very important that you see the importance of having to put it in ascending order. So my range is going to be 90 minus 34. Let's check ourselves on our calculators. The answer is 56. Okay, calculate the interquartile range. So interquartile range is equal to Q3 minus Q1. And seeing as we found our median, how do you find Q3? You find Q3 by finding then your median of the upper half and the median of the lower half. So here I've got 7 values, so I'm looking for the 3.5 value. So this is 1, 2, 3. This should be my median here, 1, 2, 3. My median on the side, 1, 2, 3, should be 46, 1, 2, 3. Okay, so Q3 is going to be 73 minus 46 equal to 27. The last one says draw a box and whisker diagram for the data above. Okay, so that is why I have this graph paper here, because we need to be chronologically correct. What do we need for a box and whisker? Let's do that first. So we need a minimum, which we know is 34. We need a maximum, which we know is 90. We need a median, which we have. And we need our Q1, 46, and my Q3, which is 73. Okay, let's get a line. Now, we want our minimum to be 34, our maximum to be 90. So we're going to have a line there and a line here. Then we want Q1 to be 46. Okay, so you should be correct in your number line scale. Okay, so let's first make our number line scale, and I think so we're going to have to go from 30s to 90s. So let's maybe go in intervals of 5. Okay, so with this being, to erase this, let's start with this being 35 and see how far we go, and if we need more of a line, we'll make it. So 35, I'm gonna go in blocks of 5. 35. Let's rather change the view so that it's easier for us to draw a lot more. Okay, that's a lot better. So zooming in now. Let's remake our line. Okay, this is going to be 35. And I'm going to extend it a little bit more because the one below would be 34. Then we've got 1, 2, 3, 4, 5, 40, 1, 2, 3, 4, 5, 45, 1, 2, 3, 4, 5, 50. It's very important that your number line is mathematically correct. Otherwise, your box and whisker diagram is not going to be a true representation. 2, 3, 4, 5. I'm going to have to extend our line. One, 2, 3, 4, 5, 70, 1, 2, 3, 4, 5. While I'm doing this, I hope you're also drawing your own box and whisker. Okay, that should be sufficient. 1, 2, 3, 4, 5, 80, 1, 2, 3, 4, 5, 85, 1, 2, 3, 4, 5. We made it to 90. It's quite a long line. Obviously in your book it might look a bit smaller. So we said minimum was 34. So here is my minimum, and we can label it 34. Maximum is 90. We can make quite a big box and whisker so it's visible. Then we've got our Q1, which we have to be 46. So if this is 45, this is going to be 46. Okay. Then my Q3 is 73, 71, 72, 73. Okay, can make that get to the same height. Okay, my median is 54. Yes, so here's 55. And then we connect. Let's try to do this line again. This is my 34 line. And we connect. And my 90 line. We're extending it and we're connecting. So that is my box and whisper diagram. So for this box and whisker diagram, the most important thing is having the correct values, which we found here, plotted on this graph. Okay, I hope that makes sense. Let's move to the next question, which is question 2. Okay, question 2 says, Learner did a project on climate change. At 2 o'clock each day, she recorded the temperature in degrees Celsius for a certain town. The information is given in the frequency table below. So we're working with data ranges. Okay, so it's got from 20 to 24, 24 to 28, 28 to 32, 32 to 36, 36 to 40, and 40 to 44. So the first question says, for how many days did the learners collect data? So that is going to be our total frequency. Okay, that is the total number of days that you would have collected this data. So on your calculator, it's going to be 2 plus 4 plus 9 plus 5 plus 7 plus 3. You should get 30 days. Okay, the next one says write the modal class. What does mode mean? Mode means the highest number of frequency. So the modal class is going to be 28 to 32. Estimate the mean of the data. Now, how do we estimate mean, which is average? Remember that mean is average of this frequency table. So what we've got to do is we have to, firstly, we have to create a new table. Okay, so we've got to add to this table and what we're wanting, firstly, is we want the midpoint of the interval. So this is the method that you should use when you're finding the mean of grouped data or class intervals. Then frequency times midpoint. So let's start by first finding the midpoint. So you've got 20 and 24. So on your calculator, I'm going to show you just one how to do it. So you're going to say 20 plus 24 divided by 2. That's the same concept for each class interval. So the first one is 22. Second one, 24 plus 28 divided by 2, 26. The next one, 28 plus 32 divided by 2 is 30. The next one is 32 plus 36 divided by 2, 34. Next one, 36 plus 40 divided by 2, 38. And then 40 plus 44 divided by 2, 42. What's going on here? Okay. Now we're saying frequency times this midpoint. So 22 times 2, so the 22 times this 2, 44. The next one is 6 times 4 is 124. 9 times 30 is 270. I don't know why I'm writing 2, 4. 34 times 5, 170. This is 26. That's why it's looking wrong. 26 times 4 is 104. 38 times 7, 266. And 3 times 42 is 126. So now to find my mean, it's going to be all of those values added up divided by my total number, which was 30 days. Okay, so it's 44 plus 104 plus 270 plus 170 plus 266 plus 126 all over 30. That's meant to be 30. So we're going to put that into our calculator. And you should get 980 over 30, which is equal to 32.666. And our original instruction said round off to 2 decimal places. So 32.67 degrees Celsius. Okay. The last one says calculate the percentage of days on which the temperature was at least 28. So we know from here, from number 9, it was equal to 28 or higher. So we're going to add all of these and divide by 30 and times by 100 because we're finding a percentage. So 9 plus 5 plus 7 plus 3 over 30 times 100. So that's 24 over 30 times by 100. So it was greater than 28 for at least 80%. Okay. That is all the stats questions that we had in these papers, in this paper. Let's go to the next one. Question 3 says, in the diagram below, we're looking now at analytical geometry. So it says in the diagram below, P is 7, 4, Q is 6, 6, R is 0, 3, and S we don't have the values, are vertices of a quadrilateral. Firstly, it says calculate the length of PQ, which should be fairly easy because we're given both lengths. I do have a picture here to help us remember the things that we're supposed to know from analytical geometry. So firstly, it's the slope formula or your gradient, which we know is change in y values over the change in x values. Your general straight line equation, y is equal to mx plus c. Your midpoint formula is important, x values being added divided by 2, y values being added divided by 2. And then my distance formula, x2 minus x1 squared. Okay, let's look at number 1 first. So number 1 says calculate the length of P. Insert form is very important because they're not going to mark your answer correct and you're going to lose out a mark if you don't leave your answer insert form. So this is 3.1, and we're using distance formula. So let's quickly look at our distance formula that's here. So we're finding PQ. My distance formula is x2 minus x1 squared plus y2 minus y1 squared. Now let's take a look at my values that I want to put in there. So my x value of p is 7 minus 6 squared plus 4 minus 6 squared. It's equal to, this is 1 squared, so 1 squared is 1. And this is minus 2 squared. And we know that minus 2 squared becomes 4. So insert form, my answer is root 5. Okay, so I'm going to just leave the answer here in case we run out of space. Okay, next one says, if t, which we don't see there, it says is the midpoint of q and s. So I'm wanting a line to go from q to s. My line went a little bit longer than normal, so q to s. And it's the midpoint of that. So I've also got a line going from this way, and it's going to be the midpoint of QS, and that is T. They're telling me that T is 7 over 2, 7 over 2. They want us to find the coordinates of S. So what are we using now? We're using midpoint formula. Because we have Q, we have midpoint, we are finding S. So it's actually you making use of that formula. Because we know the midpoint, which is 7 over 2, 7 over 2. And midpoint formula is x1 plus x2 over 2. And y1 plus y2 over 2. But let's first work with the x's. Let's keep that there. y1 plus y2 over 2. Let's work with the x's first. So x1, which I know, which is q, is 6 plus small t of s, okay, over 2 is equal to 7 over 2. My ideology of the best method to solve this would be to just cross multiply. So it's going to be 2, 6 plus t to create an equation which is then easy to solve. 2, this is 6. So 2 times 6 is 12 plus 2t is equal to 14. 2t is equal to 14 minus 12. 2t is equal to 2, divide by 2, divide by 2. T is equal to 1. Okay, let's work with my y's. So the y1 of q is also 6, plus k over 2 is equal to 7 over 2. Cross again, should give me the same value because it's exactly the same. So 2, 6 plus k is equal to 14. 12 plus 2k is equal to 14. Going to go straight to 2k is equal to 2 and k is equal to 1. Therefore, my coordinates of S is 1 is to 1. Okay, 3-mark question, but very easy to solve. Okay, so let's go and fill that in here. And on my graph. Okay, I'm going to erase this section now so that I just have more space. let's look at our next one. So we've been going through quite a lot very quickly. So the next one says, so this is very nice that they did this. So they tell you that if the coordinates of S are 1, 1, to ensure that you don't lose further marks even if you didn't get the correct value, show that PR is equal to QS. Okay, so here is PR and here is QS. I can use distance formula easily for both. Okay, so 3.3. Let's go with PR. So PR distance formulas, what we're doing, x2 minus x1 squared plus y2 minus y1 squared. X2 is 7 minus 0 squared plus 4 minus 3 squared is equal to, put this straight into your calculator, we get root 50, which is simplified to 5 root 2 in your calculator, and that as 2 decimal places is 7.07. Let's next do, what's the other one? QS. X2 minus x1 squared plus y2 minus y1 squared. Okay, root, we've got 1 minus 6 squared plus 1 minus 6 squared, which is going to be 5 and 5. It's also going to be root 50 equal to 5 root 2 equal to 7.7. For these types of questions, make sure that you state in the not just showing, make sure you actually show the examiner that you've identified it, that therefore PR is equal to QS. Okay, I'm just going to write it here that they were both equal to 7.07. Okay, the next one says show that QR is perpendicular to RS. So here's my QR. QR is perpendicular to QS. And how would we show that things are perpendicular? By using gradient. Remembering that a gradient times a gradient, if it's equal to a half, they are perpendicular. That is a very important rule. So I'm going to write the rule here. So say gradient A times gradient B is equal to -1. That means they are perpendicular. If gradient A is equal to gradient B, that means they are parallel. Okay, so in order for us to prove the rule of them being perpendicular, we've got to find the gradient of QR first. Gradient formula, y2 minus y1 over x2 minus x1. So Q is 6 minus 0 over 6 minus 3, 6 over 3, which is equal to 6 minus, oh, supposed to be putting y values at the top, sorry about that. So it's 6 minus 3 over 6 minus 0, which is 3 over 6, which is equal to a half. Now let's find my gradient of the next one, which is RS. y2 minus y1 over x2 minus x1, R and S. So R is 3 minus 1 over 0 minus 1, which is -2. Therefore, remember I said that therefores are very important. Gradient QR times gradient RS is equal to a half times -2, which is equal to -1. Therefore, QR is perpendicular to RS. So let's fill that in. So that is going to mean that there is a right angle right there. I'm going to take out some of this unnecessary information. The next one says, hence, what type of special quadrilateral is PQRS? Motivate your answer. Importantly, that we identified that there is a right angle in the corner, and one of the main shapes that have a 90-degree in the interior angles is a rectangle. So rectangle, and it says your reason is because firstly we can say that one of the interior angles are 90 degrees, and we proved that PR and QS are equal in length, so the diagonals are equal. Okay, last question. It says calculate the size of RSQ. So RSQ. So this angle right here. Okay. So what I know that we already know is that we know the length of QS. Which is 5 root 2. Okay, and we know the length of PQ, and if this is a rectangle and this side is equal to this side, this was root 5 and this would also be root 5. Therefore we can use trig because we've got that right angle there. So I'm going to work with, if I'm working with this angle, this is my hypotenuse, I'm going to use cos because it's adjacent. So cos of RSQ is equal to the root 5 over 5 root 2, and therefore RSQ is equal to, so shift cos on your calculator, root 5 over 5 root 2 gives me 71.57 degrees. Okay, this was a 60-mark question. It wasn't that bad. The analytical, if you know your formula, you should be fairly fine. Okay, let's move on to question 4. Question 4 says, given that 4 cot theta plus 3 is equal to 0, and theta is between 0 and 180, use a sketch to determine the value of the following. Do not use a calculator. Okay, so this is making use of a Cartesian plane. So I put this here to revise the Cartesian plane. So this is very important, and I found a cute rhyme to help you to remember it. The rhyme is all science teachers are crazy. And what this is that in the first quadrant, all the signs, use white, in the first quadrant all the signs are positive. In the second quadrant only sine is positive. In the third quadrant only tan is positive. And in the last quadrant only cos is positive. So if we are looking for a quadrant where cos is negative, it's going to be these two, this one and this one. And you're going to have to deduce from your y's and x values where to put them. Okay, so let's go back. Use a sketch. So we have to use a sketch, but before we use a sketch we need to first simplify this. So it's 4 cot theta is 4 cot theta plus 3 is equal to 0. We want to isolate cot. So Okay, we want to isolate cot. So, it's not a theta, it's a 0. So 4 cot theta is equal to negative 3. Divide both sides by 4. Cot theta is equal to negative 3 over 4. Okay. And it's isolating us to only work between 0 and 180. So looking at our, okay, firstly, we need to change this because our thing is only sine, cos, and tan. This is cot. What do we know about cot? Cot is equal to 1 over tan. So it's therefore equal to 1 over negative 3 over 4. So tan of theta is equal to 4 over 3. Okay. And the 3 still stays as negative. Okay, because that was where the negative was. So now that we know that it's tan, and tan is negative, and it's only falling between 0 and 180, it's got to be in quadrant 2. Okay, so for us to draw a diagram, let's draw a diagram here. It's in quadrant 2 is what we said, so we're going up and we're going down. So this here's my theta, and tan is opposite over adjacent. So this is obviously going to be negative because of the quadrant, okay? And this is 4. Here is my right angle. I'm going to need to find my hypotenuse for the use in other questions. So we're wanting the hypotenuse, let's label it r. So r squared is equal to 4 squared plus which is 16 plus 9, 25. So root of r, root of 25 is 5. So my hypotenuse is 5. So when you are drawing your diagram, make sure you fill that in because it is awarded a mark. The diagram is awarded a mark and cot is awarded a mark. Okay, but the question now that is asking us is what is cos theta. So looking at my diagram, here is theta. Cos theta is adjacent over hypotenuse. Make sure you remember that that 3 is negative because of the quadrant. This is the negative side of the x. Okay, it's negative 3 over 5. B, let's calculate B. So B wants us to find 3 sine theta sec theta over tan theta. Let's revise firstly what is sec. Okay, so what do you remember sec to be? Sec is 1 over cos. So let's just remember that. Okay, so my 3 sine theta. So let's keep this 3 out of my way. Sine theta, saw, don't forget saw, ka, to, wa. So sine theta is 4 over 5. Cos theta we said was negative 3 over 5, so it's going to be the opposite. Negative 5 over 3. Tan theta is negative 4 over 3. Put it straight into your calculator so as to not confuse yourself, and the answer is 3. Okay, next question says simplify the hence Show that sine squared theta minus 1 is equal to negative cos squared theta. Okay, so firstly let's do that. This is 4.1.2. So we're proving that sine squared theta minus 1 is equal to negative cos squared theta. So sine squared was 4 over 5 squared minus 1, and cos squared is minus 3 over 5 squared. So let's work out this first side. It equals to negative 9 over 25, and this side is also equal to negative 9 over 25. Therefore, the statement is true. Sine squared theta minus 1 is equal to negative cos squared theta. Okay, so we are done with the first part, which was making use of this diagram. So I'm going to erase all of this. Going to look at the next question. The next question says, simplify the following expression without using a calculator. So we've got cos 30 tan 60 plus cosec squared 45 sine squared 16. So without using a calculator means that you've got to remember your special triangles. Two triangles that you must remember how to draw, and you must be able to recall them. So the first one, you've got a 1, you've got a 3, you've got 60 and 30 and 2, 1, 1, 45 and root 2. This is something that you just have to learn off by heart. Like, you just should be able to know how to draw it. So you would draw it in your test. To assist you, I'm going to move it up here so we can see it. And we're going to solve for what they asked us. So cos 30 tan 60 plus cosec squared 45 I want to remove this, and the last part is sine squared 60. Okay, so cos 30, so you would look at your triangle. Cos 30 is going to be root 3 over 2. Tan 60 is going to be opposite over adjacent, so root 3 over 1. What is cosec? Remember, you must know your ratios. Cosec is 1 over sine. So 1 over sine so my sine, let's find my sine. My sine is going to be, sine of 45 is going to be opposite over hypotenuse. So it is cosec 45, yes. It is cosec 45. So cosec 45 is going to be 1 over sine squared, and 1 over sine squared is opposite over hypotenuse, so 1 over root 2, so it's going to be root 2. Okay, and remember that that is still squared. Okay, and then we've got the sine squared 60. So sine squared is opposite over adjacent, so it's going to be root 3 over 2 squared. Okay, let's now simplify. we should multiply the side first. So you're going to get 3 over 2 plus the side. We've got 2 times 3 over 4. So just put it all straight into your calculator. And we get an answer of 3. Okay, so that is special angles, special triangles. Next question is further asking us to analyze. So let's take a look at it. It says, solve for theta correct to 2 decimal places if 4 sine theta is equal to cos 37 and it falls between 0 and 90. So that's telling me it's in quadrant 1. So 4.3, 4 over 3 sine theta is equal to cos 37. I'm solving for theta. So I'm going to times by 3 over 4 on both sides. This side is going to get rid of it. I'm going to get sine theta is equal to 3 cos 37 over 4. Shift sign and solve for it. So 3 over 4 cos 37 shift sign of that answer, and we get 36.80 degrees. Okay, let's go to our next section. Okay, given f x is equal to sine x minus 1 and gx is equal to 2 cos x, for 0x to fall between 270, that's our range, sketch on the grid provided in the answer book the graph of f and g for 0 to 70. Okay, so let's do that. So before we even begin to do that, let's analyze what our graphs are. So sine x minus 1 means that it's going to be the normal sine x pattern. We know sine starts from 0 generally, and we get that pattern. Now it's going to start at negative 1. It's being shifted 1 down. Okay, so that's going to be the general pattern. For 2 cos x, we know that we're having a vertical, like a shift off the graph sides. So we're going to have to solve a little bit of for 0, let's say for 90, for 180, and 270. Okay, so put that into your calculator. So 2 cos of 0 is 2, 2 cos of 90 is 0, and 2 cos of 180 is negative 2, and 2 cos of 270 is 0. Okay, for sine, we have already decided what the pattern would be, but if you'd like to be more confident, we can do the same thing. So remember, now you're putting sine 0 minus 1. It's minus 1. Sine 90 minus 1. 0. 180 is negative 1. And 270 is 0. Same pattern. Okay. Okay, and I want my shape to go this way too. Okay, so this is 0. Let's go with intervals of 5, 1, 2, 3, 4, 5, 30, 2, 3, 4, 5, 60, 1, 2, no, actually let's go with intervals of 3, because then it makes more sense. 1030. So 1 2 3 is 30. 1 2 3 60. 1 2 3 90. 1 2 3 120. 1 2 3 150. 1 2 3 180. 1 2 3 210. 1 2 3 240. 1 2 3 270. Okay, but our restriction is till 270. So let's start with the sine one. Sine one was, well, let's use the side 2. So that's 1, that's 2, negative 1, negative 2. Okay, so the sine one we said starts at negative 1. We go up to 60. Erase. We go up to 90. So from 0 to 90 down. Let me just confirm. So it was sine 270 minus 1 is negative 2. Because otherwise our graph won't make sense. 180 is at negative 1. Ooh, it's a bit difficult to draw this graph like this. Let's take these ones out. And let's change this, our numbering pattern here, so we can get a bit. So let's make this negative 1. And let's make this negative 2. So it's here, it goes up to 90. Goes down to 180. Then we need to go to 270. Okay. It's not as accurate as I'd hoped it would be. Let's try again. 90. Okay, it's the best that I could do with this. Then we're saying G starts at 2, 1. Okay, it's going down to 90, down to negative 2, and up. So the negative 2 is only supposed to be at 180. Let's try again. Okay, so this one is my G. Okay, so let's just label my graphs. So this is G at X, and this one here is F at X. Okay, so now the questions are based on your graph. Remember that in your test you'd get a graph sheet, so it will be easier to draw on. Write down the amplitude of G. Okay, so amplitude of G is how high it is, and we could see that it's 2 units. Okay, so amplitude. Okay, next one, the range of f. So we know range is from the highest to the lowest value, and the highest to the lowest is from 2 to 0. Okay, so from negative 2, it's equal to up until 0. That's one way you could write it. The other way you could write it is y is equal to negative 2. Remember square brackets because it is actually equal to that value. Use your graph to determine the number of solutions where f at x is equal to g at x. So how do we determine that? It's where they are touching on the graph. So there's 1, there's 2. Okay, so 5.3.1, that is 2 solutions. Then the next question says the values of x in the interval of only between 0 and 180, for which sine of x is equal to 2 plus cos x. Okay, now our graph is not sine x, it's sine x minus 1. So in this question they're asking where sine x, I'm going to manipulate this question. I'm going to change it. I'm taking the 2 to the other side because that makes more sense to me. So the graph that we currently drew was sine x minus 1. They are asking for which values of x would sine x be equal to 2 plus 2 cos x. We did draw 2 cos x, that is what we have, but we don't just have sine x. So I'm going to manipulate it so it's sine x minus 2, which is very easy to draw because it's the graph that we just drew, shifted 1 unit down. So it's going to be from here, 290, going down to 180. So it's going from negative 2 up to 1. Every unit is shifted 1 unit down. Okay, so the point at where they're equal would be at 180 because everything is shifted down. Okay, you were actually able to see it from my graph even though it's not 100% accurate. So this was my original f at x graph, okay, which was negative 1. I'm now calculating for a negative 2. Everything gets shifted down 1, and those two graphs touch at 180. Okay, let's move on to our next question. So it says RQ is a vertical pole. The foot of the pole Q is on the same horizontal plane as Q and S. The pole is anchored with wire cables RS and RQ. The angle of depression at the top is 47. They give me one value to be 21 and they give me another to be 17. The first question says calculate the size of Q. So they give me a 47, 21 and 17. They do give me a right angle. So easily I can see that this angle of depression, so what law can I use, is alternate angles. So 6.1 theta is equal to 47 degrees. You can give your reason as well, even though it's not geometry. The reason is alternate angles. Okay. Calculate the length of RQ. So here's RQ. I have a 90. I have a measurement already. I can use trig ratios. And I have an angle. So how can I find RQ using this angle? Which ratio am I going to use? So I've got the hypotenuse. I'm wanting to find the opposite, so it's going to be sine. So sine of 47 is equal to RQ over 21. So make sure you change your equation. So RQ is therefore equal to 21 sine of 47. RQ is equal to 2 decimal places, 15.36 centimeters. Let's fill that in because it will be very beneficial. 15.36. Okay. Next one says, hence calculate the size of angle S, which is here. Well, I can now use the reverse. So this is also 90 because it's a straight line. So I've got this measurement and I've got that measurement, so I can use a ratio to help me find the angle. And I'm not including the hypotenuse, so it's going to be tan. So tan of angle S is equal to opposite. It's very important that your answers are correct for this type of question because you can see it building with each question. It's over 17. So shift tan 15.36 over 17. Use a calculator. 15.36 over 17. We get 42.110 degrees. Okay, the next question says, if P, Q, and S, so right here, lie on a straight line, how far apart are the anchors? So here was the anchor, here was the anchor. We just need to find PQ. How can we find PQ? Very easily, okay? So I'm going to do the question here. So I'm wanting to find PQ, so I'm going to use cos of my angle. So cos 47 is equal to PQ over 21. PQ is equal to 21 cos 47. Put that into your calculators. 21 cos 47 is 14.32. So the total length is going to be PS, which is equal to 14.31 plus 17, which is equal to 31.32 centimeters. I actually think questions like this are really easy if you understand the foundations of trig really well. Okay, we're nearly done. I think we have a few more questions left. Okay, we're now moving on to the next section, which is surface geometry. Trig is a very big part of the paper and geometry. So it says the diagram below shows a cross section of a solid made up of a hemisphere that is loaded on top of a circular cone. That is a very important point. So we've got two shapes. We've got a hemisphere, and then we've also got the cone. So make sure that you understand and remember that we've got two shapes. Okay, the hemisphere and the cone. We've got a radius, we've got a height, we've got a slant. They give me that the height is 6.5 and the volume of the cone is 83.38. So I'm going to fill in the height because that's very relevant, 6.5, and useful. They give us our formula, which is great. Calculate correct to 2 decimal places the radius of the cone. So because they give me the volume of the cone and I've got a formula for volume of a cone, I can solve for radius and I know height. So the only unknown there is the radius. So let's say volume is equal to 1 over 3 pi r squared height. My volume is 83.38. 1 over 3 pi r squared height is 6.5. We're going to change and find for r squared. So r squared is therefore equal to 3 times 83, so I'm cross multiplying that 3, 83.38 over pi and my height. Okay, I'm going to keep that exactly as is because I don't want an incorrect answer by rounding off early, and I'm going to root the entire thing on my calculator. So 3 times 83.38 over shift x times 10x on your calculator for pi, which is at the bottom next to the point and next to the word answer if you have the silver calculator, and then 6.5. And I get an answer of 3.5 centimeters if I round off to 2 decimal places. Okay, next question. Slant height, which is s. Very easy. What do I have here? Pythagoras triangle. I'm finding the hypotenuse. Okay, so 7.2 Pythagoras. Okay, so s squared is equal to h squared plus r squared. H is 6.5 squared plus 3.5 squared. It's very important that you got the ratio correct, otherwise you're going to get all the answers wrong in this question. So s is therefore equal to the root of this 6.5 squared plus 3.5 squared. Let's put it into my calculator. And it is equal to 7.38 centimeters. I think it's a very to write out on your diagram as you're going, because it helps you to be able to see things in the next question and to solve. Last question says the surface area of the solid. This is why I emphasize the importance of two shapes. Because we've got two shapes here, we are needing to use both things. So we've got volume of a cone and we've got volume of a sphere. Oh, we're finding surface area. So we need to include surface area of the cone, plus we need to consider that we've got half a hemisphere, which is this half of it. Okay, so the cone is including the top of the sphere, so we've just got to say 2 pi r squared to consider a hemisphere, because it's 2 pi r squared. So my formula for the surface area is going to be 2 pi r squared. Because we're including that hemisphere, we've got two circles, and a circle is pi r squared, plus pi r s. So if you got a wrong r value and a wrong s value, this would also be wrong. Okay, so 2 pi 3.5 squared plus pi 3.5, s was 7.38. Put it all into your calculator, and we should get an answer of 158.12 centimeters squared. Centimeters squared, very important. Okay, let's now move on to question 8. Okay, here I wanted us to also revise these shapes. So we're dealing with a rhombus and a parallelogram. So the first question says that KLMN is a rhombus with diagonals intersecting at O. LKM is equal to 34. Okay, so this is a rhombus. Let's revise the rhombus. What do we need to know about a rhombus? This is not going to be given to you in a test. You should know it, but for the purpose of this video, we're going to revise it. So for a rhombus, it's basically a square that's been shifted. And it's important to know that because it's a square, all four sides are equal. You've got opposite parallel sides. Opposite angles are equal, which differs to a square where all angles are equal. You should know that the diagonals on the same line are equal, and you've got this 90 in the middle. Also important is that you should know that the diagonals bisect each other and the angles are equal on the same side. Okay, now that we know that, let's go back to our question. So the first question says, let's fill in what we just said. So that's equal, that's equal, that's equal, that's equal, this is 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 equal, and we know we've got that 90 in the middle, so all of them will be 90 in the middle. Okay, if you filled in what you have already learned and what you have should already know, the questions will be so easy. So the first one says write down the size of O1. We already know that. O1 is equal to 90 degrees. Make sure, because we're doing geometry now, you have reasons, okay? And at the top it emphasizes, give reasons for all your statements, okay? Your reason is diagonals bisect at 90. write down the size of angle L. So now we can see that we've got created here a triangle, and we can find L from sum of angles of a triangle. So angle L1 plus angle O1 plus 34 is equal to 180 degrees. You have to give reasons, so my reason is sum of angle of a triangle. So L1 is therefore equal to 180 minus 90 minus 34. It's equal to 56 degrees. 56. We know now that L2 is also 56. We know now that N1 is 56, N2 is 56. This is 34, 34, 34. Okay. Calculate the size of K and M. So K to N to M. So they want the whole angle here. Very easy. We've already written down our information. We know what it's going to be. Just make sure that you articulate your answer correctly. So 8.1.3, firstly we've got to state that L1 is equal to angle L2, 56. Your reason is diagonals bisect the angles. Then we say that angle KLM is equal to angle KNM. My reason is opposite angles of a rhombus. Okay. And then finally, we can say that KNM is equal to KLM, which is equal to 56 plus 56, which is 102 degrees. Okay, I hope that was a good revision of a rhombus, and in a test, if you get a rhombus, you'll be able to remember the properties. Okay, let's now go to our question on a parallelogram. It says, given the parallelogram PQRS with diagonals PRQS intersecting at M, prove that the diagonals bisect each other. So this is a proof question. Let's revise our properties of a parallelogram. Opposite sides are equal, opposite sides are parallel. Diagonals are equal on the same side, and interior angles, opposite interior angles are equal. Okay, so we must know how to articulate and word a proof very, very properly. Okay, so firstly, we're going to say given we've been given the parallel lines. They've given us this is parallel, they've given us this is parallel, and they've given us this is parallel. So we've got to make use of that for proving that the diagonals bisect each other. Okay, we're proving that the diagonals bisect. So firstly, we're going to say that given we've been given parallel PQRS with diagonals. We are proving that PM is equal to MR. So we want to prove that PM is equal to MR because they want us to prove that the diagonals bisect, that they are equal. Okay, so the first thing that we need to say is we need to isolate our triangles. So I think we should work with PMS because that is involving PM, and then the other triangle can be RMQ. So that we're also including the same parallel lines. So make sure you state your triangles. So in triangle PMS, we are basically proving that the triangles are congruent. And triangle RMQ. So the first statement is that angle P1 is equal to angle R1. And you can see that because of alternate angles. So here's my parallel line. And here, oh, let's go in the opposite direction because I'm wanting P. So here, this angle is equal to this angle. We know that M is equal to M, opposites, and we know that S1 is equal to Q1, also alternate angles, and we also have that PS is equal to QR. So this line is equal to this line. So we have quite a few reasons. So let's work with the alternate angles. Make sure that when you're saying alternate angles, you say which lines are parallel. So PS is parallel to QR. Number 2 is angle S1 is equal to angle Q1. Also alternate angles. Also PS parallel to QR. And my third reason is going to be that PS is equal to QR. And that is opposite sides of a palm. Therefore, triangle PMS is congruent to triangle RMQ. Your reason, you have to state angle, angle, side. And if that is true, PM is equal to MR, and also MS is equal to MQ, which is also my other diagonals. Okay, that is a proof. That is how you set out the proof. I hope that that makes sense. It's how to prove congruency in a palm. Okay. I think we're at the end of our paper. We're nearly there. 2 more questions. Question is working with the same concepts. So it says in the diagram, 1 second. Okay, in the diagram ABCD is a parallelogram with the diagonals intersecting at E. The diagonals of parallelogram DE, so we've got 2. We've got ABCD as a palm, and then we've got another parallelogram DECF. The diagonals of parallelogram GH. FGCH, we've got another one. What other color is bright? FGCH. We've got 3 different parallels. They want us to prove that DB, here's DB, is equal to 4 of KC. So we're working with diagonals. So that is what we're going to have to work with. So let's start with what we can see. So DB, we know that this is equal to this. So my DB is equal to 2 of DE. And the reason I'm using DE and not EB is because DE is a part of the next palm that I want to go to. So essentially we're working from palm 1 to palm 2 to palm 3 to help me create the ratio. Okay, so we're working from 1 to 2 to 3 to show that DB is 4 times the size of KC. Okay, so that is the first statement. But DE, we know, is equal to FC. Do we see that? DE is equal to FC, opposite sides of the palm. Okay, so the first reason of this is we know that diagonals bisect. The second reason is we're saying DE is equal to FC. We're working from this palm to the next palm. My reason is opposite sides of a palm. Now FC is equal to 2 of KC. That we can easily see. And now we have created and involved KC and DB, which is what they want. And this reasoning is because if K is equal to KC, diagonals bisect. Okay, now we want to relate the KC to the DE. Ooh, I can already see, here's my FC, here's my FC. So that must mean that DE is equal to 2 of KC. And the reason for that is because DE is equal to FC. So we can equate them. Okay? Give a reason for each of them. So that's why we have to give statements. Now that we know that DE is equal to 2 of DE is equal to DB. So therefore DE is essentially equal to, I want to manipulate this so that I've got it of DB. So we said 2DE is equal to DB. Divide by 2 on both sides. DE is equal to half of DB. So now I'm going to change that. Half of DB is equal to 2 of KC. And that is because DE is equal to half of DB. Okay, now I'm going to times by 2 on both sides. And I've got DB is equal to 4KC. It is a bit of a tricky question, but it involves you working slowly and working with what you can see. Okay. Always remember that if you don't get to the final answer, at least you get some working out for what you see. Okay. It says triangle ABC is right angled at B, F and G. No, it's right angled at B only. F and G are midpoints of AC and BC respectively. H is the midpoint of AG. E lies on AB such that FHE is a straight line. So the fact that they're telling us that this is a midpoint is proving midpoint theorem. And midpoint theorem tells me that that is parallel to that. So it's wanting us to prove that E is the midpoint of AB. Okay, so we're proving essentially midpoint theorem. So in this triangle of ACG, okay, F and H are the midpoints, which is what they told me, F and H. I think, yeah, so F and H is the midpoints. Okay, therefore it must be that FE is parallel to BC, because this entire line is parallel to this entire line, which is what we drew there. Therefore, we're going to say in triangle AGB. So we're looking here now, AGB, okay. H is the midpoint. H is the midpoint. Therefore, HE is parallel to BG, which we have previously proved. We've already proved that those two lines are parallel. Therefore, E is also a midpoint. E is also a midpoint. And the reason is because of the line drawn from the midpoint of the side. Okay, we're going to be solving. Okay, take a look at that and then we're going to solve now, using the knowledge that we have just obtained. Okay, it says if E is 3.5, EH. So here's my EH. This is also parallel, 3.5. Okay, and the area of AEH, which is here, is 9.5. Calculate the length of AB. Okay, so we have to make use of the rules. Okay, so we know that AEH is 90 because this is parallel and this is parallel. So I'm going to erase everything and rewrite it later. So we've said that this line is parallel to this line. That is a very important point. This is 3.5. That means we're saying that AE, not that part, that AEH is also 90 because of corresponding angles. So we're working with 9.2. So I'm saying that AEH is equal to 90. My reason is corresponding angles. Okay? Because we're working with the area of a triangle, it's half of the base times the height. Okay? So the area is half of my base, which is EH, times by the height, which is EA. We know the area is 9.5. We know EH is 3.5. We want to find EA. Okay? So half of 3.5 is 7/4 times EA. So I'm going to times both sides by 4/7 to get rid of it. On the side it's going to cancel out. So EA is equal to 4/7 times 9.5. 4/7 times 9.5. It is 38/7. I'm not going to round off just yet. Okay, so that is what I just found now. I found EA to be 38/7. And because of midpoint theorem, I know that AB is equal to half AE. Midpoint theorem. Therefore, AB is equal to 2 of 38/7. And my answer, now I can round off, but it's 76/7 is equal to 10.86 centimeters. Last question says calculate the area of triangle ABC, so the entire triangle. We know the height, and we know we can find BG. Okay, BG and BC from midpoint theorem. Because EH is 3.5, B is going to be 2 of EH, so it's going to be 7 centimeters. And BG and GC is equal, so BC is equal to 2 times BG, so it's equal to 14 centimeters. Now it's very easy to find the area of the triangle. So area of triangle ABC is half of BC times AB, which we calculated. So half of 14 times 76/7. Make sure you use the fraction and not the rounded off version. And this, if we put into our calculator, is 76 centimeters squared. Okay, that is the end of this paper. This was a 100-mark question paper. I hope that you understand and that I've went through the questions in detail, and I hope you enjoyed watching this video. Thank you so much for watching.